Alright guys, in this video we're going to talk about a method of organizing data. So when data is collected from a survey or design experiment, they must be organized into a manageable form. Data that is not organized is referred to as raw data. I pull up the raw data. Now we're gonna introduce three methods to organize data. There are tables, graphs, and numerical summaries. So we're gonna introduce numerical summaries in 1.3 and 1.4. So in the section 1 of 1.2, or this video, we're gonna introduce the tables, and in the next video, we're gonna introduce the graphs. Now, before talking about the tables, I would like to introduce a new definition, which is called frequency distribution. A frequency distribution lists each category of data and the number of occurrences for each category of data. So in other words, based on the definition here, if we want to build up a frequency distribution, we need to list each category of data and find out the frequency of each category. Okay. Now, once we know the definition, let's take a look at the example how to organize the qualitative data. So the data on the next slide represents the color of mm's in the bag of plain mm's. So construct a frequency distribution of the color of plain mm's. Now we got the bunch of raw data here. So put the raw data here. So we got a bunch of raw data here, and we want to build up a frequency distribution based on the definition we just went over. We know that if we want to build a frequency distribution, we need to list each category and find out the frequency of each category. Okay, so first of all, of course, the categories over here are the different colors. In other words, if we want to find out the categories, we need to find each different color. So for different colors, we have brown, yellow, red, orange, blue, and green. And I think that's it. So as it showed over here, we put all the 6 different colors in the first column color. That's the categories. And then we need to find out the frequency of each category. So basically, we just need to go ahead to count the frequency of each color. Now let's take a look at the frequency of brown. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then the frequency of the brown is 12. And then we'll go ahead to count the frequency of yellow. We have 1, 2, 3, 4, 5, 6, then 7, 8, and 9. And what did I miss here? 10. So the frequency of yellow is 10. And then red, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we got 9 of them. And then orange. Orange is this, we got 6. Let's double check it. Okay. So orange, we got a 1 here, and then 2, 3, 4, 6. That's right. So the frequency of orange is 6. Let's take a look at the blue. Blue, we have 1, 2, 3. And I think that's it. Right? And then for the green, we have, well, let me change the color. Let's say the green. Ooh, sorry about that. For the green, we have, it says 5. Let's double check it. 1, 2, 3, 4, 5. That's right, we get a 5. For some reason, I missed the orange over here, but anyway, I think the frequency of orange is 6 anyway, and we got all of the colors in the first column and the frequency in the other column. Actually, for the homework or the test, you don't have to show me this column over here. So if it's asking for a frequency distribution, you just need to show me the first column and the column of the frequency, and then you'll get full credits. And that's for the frequency distribution. I think it's pretty straightforward. And actually, we're gonna skip this part because this part is designed for the designed for the face-to-face class. We're gonna skip this. And then once we know the definition of frequency distribution, the next definition I would like to introduce is called a relative frequency. The relative frequency is the proportion of the observations within a category and is found using a formula. The relative frequency is equal to the frequency divided by the sum of all frequencies. This definition is very important. We're going to use this definition a lot in this class. And of course, a relative frequency distribution lists each category of data with the relative frequency. So very similar to the frequency distribution. If you want to build up a relative frequency distribution, you need to list each category, of course, and then find out the relative, and find out the relative frequency of each category separately. And then you can build up the relative frequency distribution. All right. Once we know the definition of the relative frequency, let's take a look at the example here. So this is the previous example of the plane amps. So if we want to build up the relative frequency table, first of all, we want to find out the relative frequency of each category first. And we know that the relative frequency is equal to the frequency divided by the sum of all frequencies, right? So we know, I guess the green was missed here. The green was, the frequency of green is 5. So I put a 5 over there, okay? We have already had the frequency of each category over here. First of all, if we want to find out the relative frequency, we got to find out the sum of all frequencies. So we want to find out the sum. The sum would be, we just need to add them all up. So 12 plus 10, 22, plus 9, 30. 31. And then 37 plus 3, 40, and plus 5, 45. So the sum would be 45, right? And if we want to find out the relative frequency, we just need to apply this formula over here, which is equal to the frequency of each category divided by the sum. So of course, the relative frequency of the brown would be the frequency, which is 12 divided by 45, which is 0.2667. For the decimal places, in this case, in this case, they run it to 4 decimal places. And on the test, about how many decimal places you want, it depends on the instructions. I will give specific instruction for the decimal places, okay? Of course, the second relative frequency would be equal to 10 over 45, and this would be equal to 9 over 45, and this would be equal to 6 over 45, and this is 3 over 45, and this would be equal to 5 over 45. So I wouldn't change this one. I think this is like 1 over 9, something like that. So once again, similar to the frequency distribution, if you want to build up a relative frequency distribution, just relative frequency distribution, what you need is the column of the category here and the column of the relative frequency. You just need to show me those 2 columns. You'll get a full credits, okay? That's for the relative frequency distribution. And again, this part was designed for the in classroom class. So we're gonna skip this over here. Okay, let's move forward. So after the frequency distribution and the relative frequency distribution, let's take a look at the bar graph. A bar graph is constructed by labeling each category of data on either the horizontal or vertical axis and the frequency or relative frequency of the category on the other axis. So rectangles with equal widths are drawn for each category. The head of each rectangle represents the category's frequency or relative frequency. So basically, based on the definition of bar graph over here, if you want to construct a bar graph, first of all, you can list each category on the horizontal or vertical axis and put the frequency or relative frequency on the other axis. So for example, let's take a look at the previous example we went over here. I mean the frequency distribution. Where is the frequency distribution? It's over here. So in this case, if we want to build up the bar graph for that, we want to label. Oh, guess what? Actually, we don't have to do that over here because I remember we got the answer down here. So here's the answer here. This is the bar graph for the frequency distribution. So based on the definition, if we want to build a bar graph, first of all, we want to list all the categories on the horizontal axis and the frequency on the vertical axis. And we want to draw the rectangles with equal width. So each of them got the equal width. And the head of the rectangle represents the frequency of each category. So as what we got previously, we know the frequency of brown was 12, so we got 12 here. And the frequency of yellow is 10, we got 10 here. And then we got 9 here, and we got 6 here, and 3 here, and 5 here. So that's pretty much how to build up a bar graph for the frequency distribution. And there's one thing I want to mention is that when you are building up the bar graph, the rectangles are completely separate. They are not touching each other at all. One rectangle is completely separate from all other rectangles because it doesn't make sense. It doesn't make sense to make them touch each other because the brown, there's nothing in common between brown and yellow, and so forth. That's why they have to be separate. And similarly, we're going to do pretty much the same thing for the bar graph of the relative frequency. And the only difference that instead of frequency on the vertical axis, we put the relative frequency on the vertical axis. And same thing, we put all the categories on the horizontal axis and draw the rectangles with equal width. Each rectangle got the equal width. And in this case, of course, the head of each rectangle represents the relative frequency of the corresponding category. That's pretty much how to build up a bar graph for frequency distribution or relative frequency distribution. So we're gonna skip this since this is designed for the face-to-face class. And there is a special case. There is a special case of the bar graphs which is called Pareto chart. So the Pareto chart is a bar graph where the bars are drawn in decreasing order of frequency of relative frequency. So in other words, if you want to build a Pareto chart of a data set, what you need to do just put the rectangles of the bar graphs in a decreasing order. Okay, so of course this is the Pareto chart for the relative frequency distribution. So what we need to do is just reorder this bar graph over here into a decreasing order. Okay, so the only thing we need to do is just reorder the regional bar graph of the relative frequency distribution. That's about Pareto chart. And the very last thing is called horizontal bars. Bar graphs may also be drawn with horizontal bars. Horizontal bars are preferable when category names are lengthy. So basically, in this case, we can tell that the names of each category are kind of long. So we put them on the vertical axis to be organized easier. All right, to make it look clear. Actually, whatever the horizontal bars or vertical bars, they represent completely the same thing. They just kind of look a little bit different, and that's it. All right, that's pretty much all about this video. In this video, you gotta know how to build up the frequency distribution, relative frequency distribution, and the bar graphs.